pretty similar to the other one. We really can't tell unless we compare the two. We don't have how. All right, so let's just do this. Let's look at the residuals from. We didn't run this one. We did run that one. You see a pattern in there? I don't know, it looks pretty white noise-ish. Let's do our white noise test. And then let's do our mono partial autocorrelation coefficients. Nice, nothing significant. I mean, if you want to treat that little edge as a significant, it's pretty weak. I'm pretty happy with my residuals. Do I do an actual? Yeah. So I'm failing to reject white noise, which is good. It means that our model has effectively eliminated the serial correlation and ideally improved the fit as well as the predictions. All right. So let's do a holdout sample. Again, notice I'm only using the data prior to May 1st, 2010. Remember, we're still going to get a pretty decent prediction. It's not a true dynamic prediction. All right, so the fit's pretty good, you know that. And again, yeah, they should be roughly the same. The red and the, well, no, it's got a little bit different, it's got less data, so it's not going to be exactly the same. Residuals from the full sample and holdout sample are pretty similar, so they're going to be similarly white noise E. All right, you guys remember this time? Confidence intervals. Yeah, that's kind of a mess. We need to zoom in on that. All right, so here is, the gray is our 95% confidence interval, the blue is the actual, the red is the predicted. And again, this looks pretty good. Remember that we only use data up until this point. So this is a prediction, but the true data still exists, and what the prediction does is follow the actual data. So it's not a true dynamic forecast. It's what we call a one-step ahead forecast. So as good as it looks, and even though we did use a holdout sample, it's not a true forecast. So let's try, let's see what we're doing. All right, so here's the thing about our independent variables. We got the months, okay, we got that. We got time, but we also have income. So all those variables actually exist in the data. So in that holdback period, there are actual values for time, there are actual values for income, and there are actual month values. But in the future, those values won't exist, will they? So we have to actually predict for income. We can do the time stuff pretty easily. Stata will do that, but we have to actually predict for income. So how do we do that? If we had prices in here, we'd also have to predict for prices. If we had any other independent variables, we'd have to predict for all those, because our prediction is going to be based on the model, and the model is going to, we have to have all of the independent variables available in the future to predict in the future. Hence the dynamic nature of the prediction. This is one of the reasons why people use ARMA models, because it's too hard to predict for all of your independent variables. Although we shouldn't have too many independent variables to begin with. But the one that we're going to have to deal with is real income. So what do? We have to make some assumptions. Let's income. This looks like the same graph. All right, so here's income and real income. One's deflated, one's not. In essence, what we have to do is predict for this period. This is the future. This data doesn't exist right now. So in order for our forecast to work, we have to predict for those future values. Now, if we have price, that's pretty easy because the firm can control price, right? So if you're going to say, look, I'm going to keep prices the same, then we don't have to forecast what's going to happen to prices in the future. We can just say we're going to keep prices the same as we always have, and we can just throw those values into our data set. But for income, we don't know what's going to happen in the future. We could do so let's take the blue one. And we've got this. Just there. You can see those ears. We've got this little thing going on there, right? Which is what? Recession. The recession. So it's the recession. But notice that before the recession, we had a pretty easy prediction for income. Income was growing at a pretty steady rate. We've got the recession, we're bouncing out of the recession, and we've got a relatively decent prediction here. So what we have to do is make an assumption along the lines of, I think income is going to continue to grow at the rate it's been growing since probably the recession, since we came out of the recession. Because we don't really want to use the entire data set because we've got this break in the data where the recession changes. So if we assume, for example, that income grows at the rate it's growing here, we're assuming that this line just kind of continues like that. But we can also do, and this is something that if you can do this, it'll just blow your mind, your works, your boss's mind. We can also say something like on the lines of, well, what if the economy goes into the tank? What if Trump attacks North Korea or something like that? And we have a nuclear war, and nobody's drinking wine. Well, probably people are drinking more wine. Or they blow up all the grapes or something. So, yeah, the first thing that Kim Jong-un's going to go after is the grapes. It's wine country. So, but we could say, well, what happens if the economy tanks? What happens if Trump makes America great again? And we get even faster growth. So we can do these kind of what-if scenarios. And it's actually pretty easy because we're going to have this kind of neutral, best case, worst case. So that makes sense? So we've got to pick either one or all three of those. And then we can see how it's going to affect our forecast of sales if the economy changes in different, given those different scenarios. So what we're going to do is use the post-recession period as our measure of growth, which would be, let's see, and we remember how to, did I already generate time? I think so. Maybe not. So here is the log of real income. And then I just regressed real income on time after the recession. So I used after 2010. Does that make sense? So this is that. So remember when we run a log regression against time, what does this represent? The what? The what? Put it on the camera. I can hear you.
Percent.
Percent what?
Change.
Growth rate, right? So percent growth rate per period. So we got 4-week ending period. So after 2010, it looks like income was growing. And again, we only got 17 observations. So again, we're not trying to predict income. We're using a prediction of income based on kind of the post-recessionary period. So it looks like income was growing at about 0.2% per 4-week ending period, something like that. From there, we can fill in, yeah, 0.21, I guess. It's times 100. That. Per year is going to be, right, there's 13 4-week ending periods per year. Remember the Nielsen data is 13 periods. So that's about 2.66% per year, which is about right because we've been consistently under 3% growth. Okay, so we can do that. So TS report. We already know this when we time set the data. We've got data going, we've got 83 periods. We've got data going from December 2004 to April 2008. We want to add some periods to the data set. So we're going to use TS append. And we are going to add a full year, which is 13 periods. Now again, the nice thing about this is, let's go to the data set. It ends, again, in April 2011. The nice thing about TS append is it's going to fill in, it's going to create spots for the next 13 periods, the next year. Did we use TS append? Mm-hmm. Yeah. Okay, so TS append. It added it. Now, once we replace months, it's going to fill in those months. So I'm going to go back before I do that. Once so we've added periods. So there's our months. So there's our months. Okay, so notice that it adds the dates and it follows that 28-day 4-week ending period. We don't have any months, we don't have years, obviously don't have income because it's the future. But once we regenerate our month variable, it's going to fill in those new months. And fills out the months appropriately, pulls out 3 for March and the year and so on. We need this sucker though, right? And this is what we need. So we know the growth rate, it's 0.21% per year. So we just want to take this value, I think we're using real income. We want to take this value and add 0.21% every period to it. Forecasting real income. Okay, so we already did this. Yeah. Let's get out of here. This is my data editor. So we already did this, but I ran it again because we're going to use, we're going to, so yeah, generate real income equals, real income if date equals the last period, 2011. So what is it? That's real income. What did I put at the end of it? C. So what did I do? Okay. Then I just did that. So remember I ran the regression. So, okay, we're good. Basically, I'm replacing real income with income from the previous period times 1 plus my coefficient for my regression, the 0.0021. And this is only for the dates after the data ends. So what we should have is a nice filled-in set of forecasted incomes. Let's see, Jen. Yeah, is this what I did? Why is this different? All right, so. There it is. So essentially what I did was just, what did I do to one real income C, one real income half. But these are our predicted incomes based on the growth rate, the post-recession growth rate of the economy. And again, if these were prices, then you'd pick kind of an average price for months or whatever that is. Okay, so now I just want to fill that in. Forecast. Okay. Let's see. So here's using the praise command. I don't know why I switched from praise command to insufficient observations. That's good. Oh, because I didn't replace those. Let's see. So this is what I'm doing here. I'm taking those predicted incomes and putting them in the real income column. Run my regression. Remember, there's truly no sales, so you can't cheat anymore. And this is a true prediction. There is no data past that 2000 was it December 2011. So this is a true prediction of sales using income, assuming that income grew at the post-recession rate. All right, so here's our 95% confidence intervals. SEP ambiguous information. I probably generated. All right, not sure why that didn't work. Predict. Post regression.
Because it's SEPC above.
Yeah. Oh, it's already defined. All right. Okay. So I'm using SEP instead of SEPC. So let's see. Yeah, here it is. That's what it is. MEP. All right, you get the idea. Why is MEP? Yeah, there it is. You'll get confidence intervals and all that kind of good stuff. All right, so what do we know? These are called, these ARMA models are used to model underlying cycles that we have no idea the cause of. We're going to try to figure out what the order of the ARMA model is. Is it an AR? Is it an MA? Is it an ARMA combination of the two? Once we figure that out, and you always want to use the model, the trimmest model, the one with the least independent variables. So we kind of trim this down. We can look at information criteria. Yeah, those help sometimes. But once we get the model, then we can ideally improve our forecast. So, any questions? The hard part really is coming up with the model. So, is it an AR, is it an MA, or is it an ARMA? That's really the hard part is getting that. We tried different specifications. As you'll see, it's not going to make that big of a difference, one specification relative to the other. What's going to matter is that you want to get the model with the least parameters. so that you don't over-parameterize your model. And that should improve your forecast. The data set you're going to get is going to be a real data set, so we're not going to know the answer, kind of like we do with the artificial data sets that we generate. But usually the autocorrelation coefficients and the partial autocorrelation coefficients give us a good idea. And it's better to start out with a little bit bigger and then trim back. If it looks like it's a 1-1, try a 1-2 or a 2-2. You'll see that one of your coefficients, your ARMA coefficients, will be insignificant probably, so eliminate that one, see what happens, and then eliminate another one, see what happens, and kind of settle on a relatively simple model. The reason they like the pure ARMA models is because we don't have any independent variables. Everything is contained in the model. The problem with that is forecasting beyond is forecasting. The ARMA models are mean inverted. If we have independent variables like months for seasonality, and in this case income, then we can have an even richer model. So, all right, we used up the whole battery.
It's a good day.
Means it's a good day. Yeah. I need to fix my new file. All right.